The final topic for this set of videos on text processing is about phrases. You will probably not have to deal with the phrases in the assignment, but in reality, you will have to. And there are multiple reasons. First of all, of course, well, some words mean different things if they are in some phrases. I mean, United States, of course, the word United on its own will be a bit different if compared to the phrase United States. There are even bigger problems. Sometimes if you do stop word removal, you do stemming, then there are certain phrases that just disappear. And the famous example of such phrases is this. So basically, these are all stop words in English. So if you just remove stop words, you just lose this phrase and then you're not able to search for it. That's a problem. What do you do with that? There are different approaches. And again, depending on the application, depending on your evaluation, different approaches may work better. One pretty heavy approach is to use noun phrases detected by part of speech tagger. Of course, well, you have to run a speech tagger on all the texts, on all the words, all the phrases. That's heavy, and if you are up for efficiency, that's probably not your approach, but if you want accuracy and the real phrases, then you have to do that. And it produces sequences of nouns or adjectives followed by nouns, like United States sequences of nouns. Well, there will be examples. Now, a different approach would be to leave that to the retrieval phase. And when your query arrives, if a query is people are united, then, well, you don't treat united as a phrase because you don't see it occurring together with other words in the query that much in documents. But if you have a query United States, you may notice during the ranking phase that many documents actually have these words going one by one. And then you can realize, oh, look, that might be a phrase. Again, that's pretty heavy because you have to do it on the fly, but that's possible, and it has some support from indexing, and we'll discuss indexing in the next set of videos. And the quickest but the dirtiest, of course, approach, that's always like that. This is the neatest and slowest probably. This is the quickest but noisiest. It's just n-grams. N-grams is just a sequence of words. So bigrams will be detect noun, noun phrases, phrases using a part, and so on and so forth. So trigrams will be detect noun phrases using a, and so on. So you can go up to, I don't know, 4 grams, 5 grams, 6 grams, and so on and so forth, depending on how much capacity, computational capacities you have. But basically, you take a text, for example, this text here, and you extract single words from it, you extract all the pairs, all the triples, and so on and so forth. And you store them in your vocabulary. And by the way, all these things, as I mentioned before, will still follow Zipf's and Heap's law, just so that you know. And of course, if you have a lot of data, if you are running a web search, for example, web search engine, then maybe the dirty approach will work just because you have a lot of data. If you have very specific search engine, for example, for medical documents, you may really want to go for a slow but more precise approach here. Again, I can't really tell you what to use. It depends on your application and evaluation metrics that you will see next week. But you need to know that there are certain ways of dealing with phrases, and these are the ways. So in summary, we discussed 2 main things. You need to know the statistical properties of written text, and those are Zipf's law and Heap's law. And you need to know about text processing pipeline. You need to know about stop word removal, stemming, and dealing with phrases. By lexical analysis, I mainly mean getting words, removing punctuation, removing white spaces, and so on and so forth. So this is a basic material. That's why you can read it in almost any textbook on information retrieval. These 2 books are available online. And if you want to read more about statistical properties of written text, this is a very good paper on that. So that's it about text processing, text analysis. The next set of lectures will be about indexing.